Lesson 7.2 is a review of the quadratic formula, and then we'll also do some word problems involving quadratics. A cool thing to notice between lesson 7.1 about completing the square and this lesson, which is quadratic formula, is that the quadratic formula can be derived from completing the square. So you notice down here at the end of this steps and work showed out is the quadratic formula. Now, if you look at a quadratic in standard form, if we complete all the steps of completing the square, like we did in the previous lesson, so first we want to make the leading coefficient 1, so we divide through by a, then we move this constant term to the other side, then we complete the square by adding b over 2a squared to both sides. That makes the left-hand side a perfect square. We take the square root of both sides, which you can see they did here, and then finally take this one term and move it to the other side in order to isolate x. These have common denominators, so you can combine. And what quadratic formula actually does then is just allow you to plug in for A, B, and C, skip all the steps of the completing the square, and just get right to the final answer. So with the quadratic formula, basically you just need to be able to identify A, B, and C. The way to do that is to make sure your quadratic is in standard form, meaning it's equal to 0. So if we add 3 to both sides of this equation, now I can clearly see my A is 2, my B is positive 4, and my C is positive 3. So substituting into the equation, we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we can't just put this whole thing in our calculator and get a decimal. You need to make sure that you're giving your answers in terms of exact radicals. So here I would simplify underneath the radical. I would see that under the radical I'll have 16 minus 24, which is negative 8. Right away I'm thinking this is going to be an imaginary solution then, since there's a negative under a radical. So first of all, the square root of 8 we know is 2 root 2. And then like we just said, it's also imaginary because of that negative number. So we have 2i root 2. And now we can go ahead and simplify this because both the first term and the second term are being divided by 4 because it's all over 4. So that means we can reduce negative 4 over 4 to negative 1. And here we can reduce this to I root 2 over 2 because the 2 and 4 would reduce. And there it is, x equals negative 1 plus or minus I root 2 over 2. We'll just do one more of those. So we need to be able to identify A, B, and C. So let's get this into standard form. I'll distribute the 4x for 8x squared plus 12x. And then I'll subtract 5 from both sides to get 8x squared plus 12x minus 5. So I can clearly see here my A is 8, B is 12, and C is negative 5. Include that sign there. So we have x equals negative b plus or minus the square root of b squared minus 4ac is negative 5 all over 2a. So now you just simplify. Under the radical, I can see that I'll have 144 plus 160, so that's 304. Square root of 304 can be reduced into 4 root 19. And then thinking about these terms as both being over 16, I can reduce both. Here I can divide by 4 and I'll get negative 3/4. Here I can divide each by 4 again and I'll get 4 left in the denominator, so root 19 over 4. So we can write it like that, or we can leave that common denominator, so it's negative 3 plus or minus root 19 over 4. Okay, here's a word problem. We're going to have to write a quadratic equation and then solve it by any method of our choice. So factoring, completing the square, or quadratic formula. Those are the three we know at this point. So it says a 6 by 5 rectangle has each side increased by the same amount. And this results in an area that's triple the original area. Find the amount of increase. So let's define a variable. Let's call x that amount of increase we're looking for. Tells us originally we have a 6 by 5 rectangle. I know that has an area of 30 just by doing length times width. So it says you take this rectangle and you increase each side by the same amount. So I'm going to increase the 6 side by x, and I'm also going to increase 5 by x. So there's our new rectangle. The problem told us that the new area is triple the original area. So triple of 30 is 90. Now I can write a quadratic formula because I know area is length times width. I know the area of this rectangle. I have an expression for the length and width. So now we're going to get it in standard form of a quadratic first. So we have 6 times 5 is 30 plus 11x plus x squared. And then we want to get it equal to 0, so I'll subtract 90 from both sides. So when I do this 30 minus 90, I'll get negative 60. Again, at this point now you have a quadratic in standard form. You can use any method you want. Quadratic formula, completing the square, or factoring. Factoring is always the fastest. If you can see this factors quickly, that's what you're going to want to do. And this one I can see that because I know negative 4 and positive 15 will multiply to negative 60 and add to positive 11. So setting each term equal to 0, I get x is 4 and x is negative 15. So the question asks for the amount of increase, so we can't have a negative side length, so that's an extraneous solution. So our final answer then is that the amount of increase is 4. This problem didn't have units, but let's pretend they told us it was inches, so 4 inches increase. So that was lesson 7.2. You can see Schoology for your homework assignment.